Okay, yeah, recording now. Okay, who can tell me what the command digital write 10
So we have
high will do?
one answer in the chat so far. Does anybody else know?
What if there's no LED in there? It's just we'll send electricity through pin 10. Yeah. Yeah, that's correct. The pin 10 voltage will be set to a corresponding value of 5 volts. And that 5 volts can be measured in relation to the ground. So if you just put like a little load or of something like a motor or LED, that device will activate. What command do we use to pause the code for 1 second? Okay.
Delay 1,000.
1,000 milliseconds. Yeah, that's correct. What value can we use on analog write to send steady 5 volts on pin 10? That one we didn't quite cover, so I'm gonna have to explain you this. There are 255 steps of levels of signal on any of the pins. So when we say high, it's basically equivalent to 255 steps out of 255. So this is the maximum amount. And this looks like this. So digital write in reality is not quite proportional to the voltage. It's more of a width of the pulse. So Arduino creates pulsed inputs. So if you put analog write 0, you get 0 volts, no pulses. If you put analog write to your pin and the value would be 25 duty cycle, 25%, which is what, 50, something like this, 50, 75, you're gonna get that kind of pulse structure. A short pulse, long pause, short pause, long pause. 50% duty cycle, you get pins with exact same width, on and off, going super fast. You cannot see it with your naked eye. If the LED is connected to it, it just looks like it's turned on all the time. But if you start moving it in front of you, you're gonna see trace of the light. I'll try to demonstrate it if my camera can support it on the computer. 75 duty cycle has, of course, wider on pulses and shorter off pulses. And the full 255 level is going to get 5 volts without any pulses straight, steady 5 volts on it. Okay, so each one of those levels indicate different brightness of the LED. So if you would like to play with it and try to turn on your LED with different brightness, you can try to use that command. Instead of high, put the different numbers in it from 0 to 255 in your code and see how it's going to affect your device that you have connected to it. So this is kind of a dimmer type of situation, digital dimmer. So if you have dimmer at home, you know what I'm talking about. You press a button and your light in the room goes a little bit dimmer. And the same thing in here. You can control speed of the motor, for example, if it's connected to the digital pin, or brightness of LED.
So Alex, really quick, let's go back to that for a sec. So if we're looking at this, right, just to make sure that everybody understands, if I have a light bulb hooked up to it, what will be the difference between, for example, the 255 and the 127? Does anyone know? What does this mean?
I do.
Yeah? What does it mean?
Basically, so 255 will be a little brighter than 127.
Yeah?
Twice as bright, actually. Yeah, 127 is like a halfway there between 0 and 255. So if we can have LED connected to pin 10, we can put pin 10, 127. That's going to make it LED light up half as bright than if we put it to 255. There you go. Okay?
Awesome. Cool.
Awesome, awesome. All right. This is the command. My PowerPoint, sorry, if I put it in the presentation mode, it kind of screws up everything on the Zoom, and I don't see anybody's answers. So what pin mode command is used for? Who can explain? We use it usually in a setup function.
If
right
you know, send a message so we know that you know. No one knows? If you're shy, you can send a private message. If you're not sure if your answer is right, it's better to guess. Then we know you're still alive. No one knows.
Okay. Fair enough. Pin mode command is used to set pin to input or output mode. So there are two ways that pins can be initiated on the, yeah, exactly, Druid knows it. So if, for example, you're connecting some sort of sensor to your pin on Arduino and you're expecting to read from it, then you put your mode to input. That means that the Arduino will be turning that pin into some sort of ear to listen to that sensor. If on the other side you connecting your pin to some sort of device that will make work for you, like LED lighting up or a motor spinning or buzzer buzzing, then you need to put that pin into output mode. And this is just a way that Arduino manages the internal workings of the circuit for those pins. All right. And well, here I have an answer. How does Arduino read analog sensor value? First, we set the pin mode to input. And then whoever is eating something there off the plate, please mute the computer. And then use analog read on the analog pin that sensor is connected to read that value. And you noticed yesterday it was a little bit kind of confusing to some that when you try to put the values you read from your potentiometer into the serial monitor, rather than 0 and 5 volts, you get all kind of numbers going all the way to 1,000. That's how the analog to digital converter inside Arduino works. It takes your analog value from 0 to 5 volts and maps it to the value from 0 to 1023.
Could you please mute your mic, Katerina? Yeah, thank you.
I don't think it's Katerina.
Yeah, I think it was.
Okay. All right, good job here. So today, what we will do, guys.
One sec, just before we go into anything else, today is actually Alex's birthday.
Oh.
So,
Alex.
if anyone knows, I think we should do a little bit of a congratulations. Happy birthday.
Thank you very much.
Yes. Okay. So everyone be extra nice to him today.
Happy birthday.
Everybody's always extra nice to me. This is an amazing class. Okay. So guys, we have our photosensor schematic that you should, guys, most of you who didn't disassemble it yet should have it since yesterday. And we have a code that takes that value of the photosensor, and we were using it to control the frequency of the light. But today we're going to cover 3 different subjects. One would be conditional statements, meaning that if something happens, then some action going to take place. So we're going to use the if statements to check for condition, and if condition is met, we're going to do some different type of work. So in this schematic, we'll be turning on LED if it's dark and turning it off if it's light. Then we're going to go through cycles and loops. We already know one loop, which is the main loop of the program, but there are all kind of different kind of loops, and we also need to know them to write effective and compact, super efficient code. And also the third thing that we're going to do today is we're going to learn how to write our own functions, because that will save us space, and we don't like scrolling through long programs. At least I don't, and I know that you probably wouldn't enjoy that either. And knowing how to write functions will make us to write a super compact, very easy to understand code. You will by end of the class, you will understand how it is going to be, how it's going to help you to write super multifunctional code there. Okay, so we'll start with the ifs today. So let's pull out the Arduino IDE. I will keep the schematic on. For those who broke took apart your circuit from yesterday, please, you feel free to go to Tinkercad, open up the Alex photosensor sketch, put it back together. We will test it, and then I will bring up the code from yesterday, and we will introduce some if statements there and see how it works. Okay?
I put mine back together already.
Terrific. Okay, let me see. Variable blinker, I think that's the code that we were using. Yes, that's the one that we were using yesterday. So let's go through the code real quick. Let me make it larger so that everybody can see it.
That's not the code that's on yours. It's a different code on yours.
It should be the same for everybody. What we were using the exact same code for potentiometer and for the.
Can you put it in the chat?
You want me to put it in the chat? Yeah, I can.
Yeah,
put it
because
in the
I
chat.
can't find that code anywhere anymore.
Yeah, absolutely. Let me put it
Okay,
for
before
everyone.
we go on, Alex, since you're introducing if statements and loops, and we have some kids who doesn't have coding experience at all, so can we please explain first these concepts to kids?
Yeah, of course. It will be very self-explanatory. I will put this if and we will go through it and we will understand how it works.
But just high level, just before we dive in. Tim or Emily, do you want to take lead on this, please? Can you please explain?
Sure, yeah.
If statements?
Let's think about it, right? So essentially what we're going to use today are some conditionals. And what if statements and loops do is that they control flow. And so they are called flow control. An if statement is just as it sounds. Basically, you're only going to do something if a condition is met. So if I have an if statement that says if, what variables do we have? If sensor value equals 3, do something else, you're not going to do something else until my sensor value equals 3. So the idea of the if statement is just you have some condition that needs to be met, something needs to happen before something else that you want to happen happens. And the idea of a loop is, you guys know this lots already from your code, a loop just continues to run the same code over and over again. Depending on what condition you put in the loop, some loops run forever, or just as long as your code is going, and other loops will run until something happens, kind of like a conditional as well.
Okay, let's do it actually. It will be way easier to understand than just a verbal explanation of it. So I will introduce if right here, so in the middle of our loop. So after we have acquired our sensor value, we are going to do the if, and I will copy so that this time there will be no spelling mistakes. If sensor value, let's say below certain level, we will have to determine what is a twilight number for us. Because for everybody in your rooms, lighting conditions are different, and the resistor value that you have chose might be different from one another. So for one of you, the twilight number would be 200, and for some of you, twilight would be 10, and for others would be 800 or 1,000. So we're gonna have to kind of find this. I'll show you how we do it, but for now, I'll put it for 100. If sensor value is if 100, we're going to do something, right? So how it works in Arduino, you put like a curly bracket, and anything inside that curly bracket will be done. That command inside curly bracket will be done if that condition is correct. So if our sensor value is less than 100, I want the LED to turn on. So I'll just copy this thing from here and put it in there. So what's going to happen if that condition is false? We're going to have to put another keyword there that's called else, and put another set of curly brackets. And in case if it's else, then we're going to turn off the LED.
Oh, wait.
Super easy. And I will delete all that thing because we don't really need it. But what we need here is we need a little bit of a delay, like a 50 units, which is 5 milliseconds, like that. So look at our code now. What happens here is that this loop goes over and over again, and every time it goes on, we check in sensor value from our analog A0 pin. Every time that 0 pin is less than 100, and when we check for that value, we're gonna turn on our LED. And if it's more than 100, we're gonna turn it off. So let me actually connect my Arduino here and see.
Does anybody have any questions? Does that make sense to everybody?
Wait, can you just wait a minute? I'm trying to put the coding just for the LED, the sensor, because I took it off to put the potentiometer.
Okay.
But so I just need to put it.
Do you need the diagram?
No, I'm looking off the chat.
Okay.
So let me see. I will push that code over.
In the meantime, does anyone have any other questions? Does that make sense to people? Can you write a yes in the chat if that makes sense?
Or can we like copy that because
Alex, can you send the copy of the code?
So look, my resistor shows 220. So, but I'm using potentiometer. I don't use the photoresistor, so I can go all the way to 1023 and all the way in the middle. So my threshold value can be anything. I currently have 100, and my LED is on. So as soon as I go over 100, my LED turns off. Let me close it off. So
Alex, do we want students to write this in their code?
I can share it. So if you guys
Okay.
not a typey kind of person, I noticed that in any classroom about 50% of people don't really like typing because one little spelling mistake, comma misplaced or something like this creates an issue. So Al can paste it. You can just snatch it straight from the chat. Everyone. Oh, Katharina is in the waiting room somehow. What happened? Is she kicked off? Oh, it's another device
Yeah,
you might be using.
I
Katharina,
can't.
I'm accepting you're there, so you can get in.
What's up, Ricardo?
The problem is
I'm not in the
I
waiting
tried
room.
copying, but it didn't work.
It didn't work when you copied it over?
Yeah, it says copy error message.
I'm not in the waiting room. That's for sure.
There you go.
Try that one. So we just sent another one. Copy and paste that in and see if that helps.
Catherine, I have two of you here. So is it both
No,
you?
it was an error with the copying.
Oh, how are you copying?
I'm doing Control-C, Control-V.
Yeah, they're both me. One's from the computer, and I'm just
Okay.
using that for copy and paste. And the
Okay,
second
good.
one is the one that I'm listening through.
Ricardo, try one more time and let us know if you still have a weird error coming up. Okay, so Alex just sent you code, so try to copy that in. If it still doesn't work, maybe we can go into like a breakout room and try to fix it.
Also, guys, when you copy paste code, sometimes it gets really crooked. So like
Actually,
everything you
yeah.
put in there might look like really flat, like this. You know, all the lines are jammed together and it's hard to figure it out. There is the auto format option here. So you can select auto format and it will bring everything to nice and padded code that will be easy to understand. So try to use it as much as you can, especially when you're copying it from a chat window, which might not always look nice when you put it in.
Can you show that again? Where is it?
It goes into Tools, Auto Format, or you can use Control-T shortcut on a keyboard to format your code. So it's going to do all the indentation for you when necessary. For example, if you do the if statements, usually it's a common practice to make sure that the work that needs to be done if condition is true is a little bit indented to the right. This way you can see where you can see where the if starts and ends. So now, guys, a second step after you assembled it and run the code is to
Wait, Alex, let's make sure everyone's actually code is working. So
yes, I'm still on it. Once you guys done this thing, we need to find twilight number for all of you. So you need to decide what is the period, what is the lighting level for you that you say it's coming from a day to night and it's time to turn on the lights. So you need to go in here, start your serial monitor, and then try to cover up with your hand the potentiometer to kind of simulate night condition. So night has come, you close your photoresistor with your hand, and you see what value it comes to. And then you get hand off, and you see what value is a daylight. So your twilight would be somewhere in the middle of them. So for example, if I'm removing my hand and my light is like 0 or 50, and then I'm putting my hand on top, and my value becomes 200, I will say my twilight would be about 150, and I put it in there, and that would be a good kind of a reliable point when we go from no need lights to let's turn on the lights.
Can we see your contraption there, Alex?
My contraption?
Yeah.
This one?
No, your actual physical Arduino.
Oh, physical Arduino? Well, I have potentiometer stuck on it, so it's not going to help you anything.
Can you replace it with photoresistors so the students actually see?
Yeah, sure.
Yeah, thank you.
All right, so in the meantime, let's make sure everyone's caught up. So Ricardo, does yours work now?
And no, still the copy paste isn't working.
Okay, Tim, do you want to pull Ricardo out into a breakout room and see what's going on?
And Kranti, can you pull Kranti too? She needs help too.
Yeah, sure. Alex, can you just put me in a breakout room with anyone who needs help?
With Ricardo.
Coming.
Mhm.
Assign. Okay, so Ricardo and Tim.
And Kranti.
And Kranti too.
Mhm.
And
Alex?
Kranti. Yeah.
I can't seem to get the code downloaded onto my chip.
What are the errors?
I gotta see. It doesn't really say.
Usually, if it doesn't download, it should say either port is not correct or
Problem.
There-
Problem updating board. Updating to board.
then in this case, just try again. Sometimes it doesn't do it from one first try.
It keeps doing. I've tried it like 70 times.
7 times, then unplug Arduino, plug it back in.
Huh?
That also happens.
Alex.
Ian has a question.
So right now,
Doesn't work.
the thing says that it's 300, even though I'm not covering it.
What?
So
No.
it's going up when I cover it.
Yeah, so basically your nighttime is the high number and your daytime is the low number. So you should take the number between them. So for example, if you said 300 when you not cover it,
I didn't.
Yeah,
Yeah.
so and when you cover it, how far it goes?
it goes all the way up to 700.
700. So I would suggest somewhere around 500 would be your evening kind of a twilight area. So put your value when you check in it for 500. And then load it up into your program again, and then see when you cover it up, you should have on and off situation with your LED. So it will be on when you cover and off when you're not.
How do you get to that page where you find the twilight time again?
You need to open up serial monitor. So
Oh, that's cool.
The magnifying glass on top right of
yeah,
your.
exactly.
Alex,
Oh, okay.
Alex.
Yes.
It says
I
board
have
at
a
null is
problem.
not
So first
available.
of all, when I'm not covering it, it's like at the 1,000. When I cover it, it pretty much doesn't move, and the light LED doesn't light up when I cover it and when I don't cover it.
Alex,
just
Oh, what does your
light
serial
up.
monitor shows, Catherine?
1,004, and I'm not covering it. And when I cover it, still says 1,004.
Still 1,004. So you need to do something with your schematic. It's either resistor is wrong or you're not connected it correctly.
It would help
Do
if
you
you guys
mean
can
like
choose-
resistors are not the correct resistance, or?
Yeah, that might be it. So you need to use a resistor of like 1K or maybe higher, maybe up to 5.
it says board
I'll
at null is
try
not
that.
available.
Let me,
Ian, do you want to share your screen real quickly?
Yeah, sure.
So Kranti, you're back. Did help?
Oh,
did it help you?
sharing is disabled.
yeah, let me see. I'm done uploading. Now I'm using photoresistor and my value is 600. If I cover up with my hand, it goes to 900. And if I remove it, it goes to 600. And I'm sitting by the window. So for you guys, like for example, if I take my phone and I turn the flashlight, guys don't whistle, and I shine on the resistor. When I like shine directly with my flashlight, it goes as low as 200. If I remove flashlight, it goes to 600. And if I cover with my hand, it goes to close to 900. So for me, the twilight, I would choose probably around 700-ish.
Or is that just the headset?
All right. Also, Alex, somebody said that they can't screen share. So do we want to adjust the screen share settings so that they
No,
can
I need to stop sharing so that they could start.
Okay,
It's only
there
one
you go.
person at a time.
Oh, okay. Okay. There
There we go.
says board at null is not available.
Board is not available.
Yeah.
Okay, let me do.
It's serial port not selected? Did you go through the 2 ports?
Oh, that was before. That was before.
Oh.
Right.
Okay, let me see. Tools. Where is it going? Okay, port. Here it is. You need to select the port that says Arduino.
Oh.
That's what I mean. Yeah, that's exactly what I said.
Compiling sketch, and it should be uploading, and it's done uploading. Here you go.
It's supposed to be column 7, not column 9.
So right now, if you turn the serial monitor, you should be able to see the values. I don't see it because you're only sharing the window, not the entire screen. So you should see the numbers running into your
I
serial
can see
monitor.
it.
Yeah, and try to cover it with your hand, and then see if the logic actually works for you.
Yeah, it goes up to 1,000 when I cover up with my hand.
Yeah. So I'm stop sharing you here. So did everybody get the clear idea of what that twilight zone kind of calculation is? You need to find the 2 areas. One is for bright condition and one is with the dark condition. And then your twilight would be right in the middle somewhere. And why is it important that we need to know that everybody might have different numbers? Why? Because everybody's sitting in a different room. Somebody have lights on, somebody have lights off, somebody's sitting by the window, somebody's not. So your situation with the numbers that your photo sensor will be registering are all different for each one of you. That's why you need to open up serial monitor, do some sensitivity test with your hand. And then when you figure out what is your high value and low value, you put that threshold inside your if statement to that middle twilight area. Okay, let me share the screen again.
Okay.
So that value here, 100, should be your middle ground between maximum and minimum. Okay, so for me, if you see my numbers running right now, it's 600 for not covered, and 900 for covered. I would say 750 would be my number. So I'll go 750 here, and I upload it, and that would be my LED turning on situation. So right now is a daylight. Actually, for my case, I should be not less. It should be more, like this, more than 700, because it's on normally. So right now my LED is off, and if I cover it with my hand, it goes on. There you go.
Blinking.
Alex, let's spend the next 10 minutes making sure that everyone actually.
Let's do that. Yes.
Yeah.
I have a question.
Yeah. Go ahead.
Do both resistors have to be the same?
No.
Okay.
The
one that from the LED I have it is the 220, and then the one through the theme Bobby, I forgot what it's called, is 1,000. Do I need to like make it higher or something?
1K, right?
It's still not working.
Because your numbers are below 400 and then go over 400, right?
The one on LED is correct, but for the photoresistor, you need 1K, right, Alex?
Yes. Yeah, I used 1K for photoresistor and 220 for the LED. LED
That's
is
exactly what I did.
Yeah.
Actually.
Yeah. So, Katerina, is your LED blinking at all? Lighting?
It's not even lighting up.
Okay, so Katerina needs troubleshoot. Kranti needs troubleshoot her LED.
I will put Katerina. Is Tim back, or Tim still working with the guys?
Tim still helping Ricardo. And Kranti is actually was first on the line. She texted me. Can you put me and Kranti maybe in the room? And Emma, do you want to help Katerina troubleshoot?
I can take a look.
Yeah.
Okay, mine works.
Alex?
Yeah.
Alex, mine is backwards. When I cover it, it turns off. And
Yeah,
when
change the sign. Change the sign here from less than to more than. It's just the arrow should be pointing.
Oh,
right,
okay,
not
yeah,
left.
that was the same.
Do
with
that
me.
and it will correct it. The other way of doing it is changing the high and low with its trade places. So if sensor is less than that, make this too low, and in the L situation, make it too high. That's one way, but it's way easier to actually just mirror the sign. Make that sensor value less than twilight, make it sensor value more than twilight. Okay, my breakout rooms, I have only one breakout room. I don't know if I can create another one, and Ricardo and team is there working.
Oh, you have to create it in advance, I think. Ryla had the same issue.
Yeah, okay.
Yeah, we can create another breakout room while they're there. But once they are out, you can create several breakout rooms and just send us to separate rooms.
Okay, so is Catherine who needs help?
Okay, let's just do that online then. Katerina, can you turn on your camera and just show it to us?
Let me stop sharing. Catherine, if you want, you can share your screen. We're gonna all look at it and learn.
Yeah.
Okay, so
Share your screen that
I'll
you
share
have
my
your code
screen
on.
on the code one. So on the computer is where my code is.
And currently, at the meantime, can you copy paste your code and just send it to me in the chat? I want to check your code first, okay?
And that's that. One sec. That's there, and then.
Okay, so your port is reading numbers. So when you cover your resistor, nothing changes?
It's going down to 100.
I don't see any changes in the numbers.
Man, it's covered. That's not resistor.
It's not 250.
So, Catherine, is this your screen, right? So try to cover up with your hand and see if it changes anything.
Yeah,
I have already.
So you're covering right now?
Yep.
Now remove the hand. So it doesn't change anything, does it?
No,
nope.
But because if sensor value is less than 100, she puts.
No. It doesn't matter right now. At this stage, we're trying to see if the sensor even works.
Yeah,
so if sensor would work, you would see these values change and be different between you cover it with your hand and not cover with your hand. So this next step would be for us to look at your
wiring.
Actual wiring and see how you do it. So let's somehow trace the part of your circuit that has photoresistor connected. So you should have one leg of photoresistor connecting to the negative bus. Is that correct? Okay, I can maximize it somehow, your video.
Yeah, let's just get the speaker view.
Basically, this one.
Okay, can you walk us through your wires that go from
so this one is the wire that connects it from the ground bus to the thingy. And then the resistor, that's 1,000, goes through here, and then this wire connects it to the plus.
Okay, and the one that is listening, on the A0, it connects to the point when photoresistor and resistor holding hands, right?
Yes, it connects right.
Bring it closer. Bring it closer a little bit. Let me see.
Yeah, there.
This one.
Oh, it's not a photoresistor, dear. This thing is the temperature sensor. Take it off.
Oh, wait,
Put a photoresistor on it, please.
Yeah, the photoresistor has a snake picture. It has a yellow head and a snake picture on the top.
Yeah, it has a little kind of it's like a little tablet with a snake-like thing on the top.
Oopsie daisies, my bad.
Yeah, that's probably what it is. Because temperature doesn't react that much to the light, you know?
Mine doesn't work too.
Who was that?
Druva.
Druva, okay. So you're next. Can we look into Cranty's, please, contraption? Yes. Yeah, that's the one.
Yeah, that's the one. Replace your temperature sensor with this thing.
My bad, I'm sorry.
It's okay.
I can see that it jumped to 1023 already.
All right.
Let me know, Catherine, when you're done replacing it.
Hello.
You done? Okay. So do we look at Cranty's now, or?
Yes, let's look at Cranty's. She's been
Drew, yeah, that's correct one. Yes, that's the one.
Okay, Cranty, go ahead and.
Cranty, share your screen. Let's look at your.
Alex?
Yeah.
I've been only when I touch mine, it turns on the light.
And my
that means that your twilight is too close to the value of your max value. So try to change that number in the if statement. So when you cover your sensor, you should get max value, and then when you remove your hand, you should get min value. So try to put the number of the twilight somewhere right in the middle, not too close to the maximum, because this case you're gonna have to like really physically touch it to activate the LED.
Okay, Kranti, can you click on tools and comb just to show us which port you're using? Tools?
What?
Oh, okay, so you have the numbers. Oh, no, that's okay. Yeah, just. Okay.
It's at maximum, whatever she's reading
So
there.
what happens when you cover the sensor?
I think it's a schematic problem there. I think she's just short circuiting the.
We need to trace your wiring to make sure. Alex, can you open again the diagram?
Yeah, actually, she can do it. She's in Tinkercad. She can open up the Alex photo sensor sketch.
No, for me, like, okay, I can open it probably too.
Are you controlling it?
No, I'm not.
Is it Kranti controlling it? Yeah. So do you see how it's here done? So you have, that's, yeah.
Can you bring your Arduino to the camera so we can actually see? Kranti, can you show us your Arduino?
Kranti, just show the inside onto the camera on the computer your circuit. We'll try to look if there is any wire missing.
Oh, perfect, excellent. Yeah, just move it a little bit.
Bring it closer, and move the circuit so that we could get a better look at the place where the photosensor is.
Okay, so show us where is your photoresistor there?
Like, oh, that. I can't find it right now.
Your photoresistor is not on the board yet?
How does it look like?
Okay, so you have to put the photoresistor on your board, following the diagram. And the photoresistor looks like, okay, in my set it came in this bag, right? And it looks...
This one?
With a little snake on the top. Yes, I think that one, yeah. Does it have its little snake kind of picture on the top?
Yeah.
Yep, that's the one. Yeah, like this one, right? Okay, make sure to follow the diagram when you put that in. So when you put the photoresistor on your breadboard, from there, make sure you just follow its legs, right? One leg gets connected to the negative circuit, and then the other one gets connected to the to the positive through resistor, and then to the analog 1 port. So that's what we want to see.
Okay, it's working.
It's working? Can we see?
Yep. Sure.
Oh, that was Katerina, right?
Yeah, that was me.
Oh, okay.
I also set the
Right. And when you cover it, perfect. Yeah, good job, buddy. Good job, honey. Yeah. Okay, Kranti, how about you? Can you point? All right. The thing is, when you have only one camera, right? When you point down, then you don't see the diagram, right?
Let me do something here. I will share the screen, and you will see how it's assembled, and you compare to your stuff.
There you go. That's perfect.
Take a look at this, Kranti. You see how it is connected here. So one leg of photoresistor goes to negative, another one to this row, which is rucksack row.
Wait, Alex, but this is not how you showed on diagram.
It doesn't matter. I just didn't use wires because it's easier this way.
Oh.
I connect directly. This resistor goes to plus, photo element goes to minus. And in one spot when they're holding hands, you connect the yellow wire, and yellow wire goes to A0.
Okay, so those of you who have trouble, maybe try this option, because then you don't get lost with wiring, right? Sometimes when you put too many wires, you kind of lose track of what goes where.
Which wire goes on which part on the circuit?
So the orange wire goes to the A0. These two guys, yellow and orange, is this ground and plus 5 volts. And this guy goes to pin 10.
Okay. I just take a few wires out.
Okay, so Katerina is good. Ajvat, you good there? Will, your contraption works? Can you guys give us yes or no in the chat, please?
Mine works.
That was
I'm setting mine up differently.
Okay, good.
Mine works. I don't know about Rylan though.
Okay, well, can you please check him and help if he needs help, please? Yeah.
Rylan isn't done putting it together yet.
Okay, keep us informed. And since you've done yours, you're really good at it. Can you please help him? Yeah.
Yeah, mine works.
Okay, Ajwad's work, good. Ian, I think we saw yours one working, right?
Do you know how?
Yep,
Oh,
it works.
Okay, so we're only waiting for Kranti, Truvar, and team is working with Ricardo, right? Yeah, I think that's okay.
Can you go back to the picture?
Just a second, I'm getting another one.
Yourself? No. No.
There it is. Is this better?
Yep.
You can see where the wires actually go to. So this is the pin 10, that's the one that is controlling our LED. And now this is A0 that is going to the place where the photoresistor and 1K holding hands. And one end of 1K goes to plus red, and another end of photoresistor goes to negative.
Mm-hmm.
And these two guys just supply power to the entire circuit.
Yeah, so remember your power, like those side plus and negative buses, they called bus. They're like just like a highway, right? You just power it with electricity so that you can actually take electricity and bring it to the board, right? So that's how it works. On the middle part, the electricity goes like row wise, but on the sides it just goes like a highway, right? Vertically. Yeah. Would be nice if these boards were actually transparent, like on that video, right, Alex?
Yeah, well, whatever comes with the kit, right? We can do them separately.
Yeah, that would help just to visually see where the electricity can actually flow, right? You can see the metal clips actually.
So tolerant.
What do you want?
Yeah, you need help?
Is your microphone? No, it's not.
It's always just two processes, right? One, you need to assemble.
My mic is on.
You need to assemble your Arduino board, and second, you need to make sure your code is correct, right? Yeah, Ricardo is back. Hey, buddy.
The whole thing. I'm trying to turn it on.
Team, how is it going with Ricardo? Everything fine? He's caught up?
Yeah, Ricardo has his LED turning on now whenever he covers the sensor now. So.
Awesome. Good job, buddy. Good job.
Did you guys do anything else while we were gone?
No, we were helping the other kids. Alex, now that team is back, can you create a breakout room?
I'm just putting the last
What needs to go to breakout room now?
No,
Did you still need help?
Create them.
That number, it's too low.
No.
Okay, guys, can you please mute your microphones if you're not talking to us? Because otherwise, we kind of have to talk over it.
Okay, I have now 4 rooms. If you need to go
Yeah.
to any of the rooms.
So, yeah, Tim, can you take maybe Kranti to the room? And I think.
Granty and Tim are assigned to breakout room number 1. You're welcome to go there.
Mine works.
Dhruva, you're done, right? Good job.
Yeah.
Excellent. So
Alex, did you close the breakout rooms? Because I can't see it anymore.
Okay.
Okay, how about now?
Yeah, there you go. Okay, I'll take Kranti in there now.
Yeah. Yeah, Tim will help you there, okay? Perfect. Okay, I think we're all caught up now.
Yeah.
With Kranti and Rylan. How's Rylan doing? Well, can you update us on Riley's or on Rylan's, on your brother's status there?
Sorry, what?
Can you update us on Rylan's progress?
Oh, his is backwards just like mine was. We're trying to fix it.
Okay, good. Yeah, he's lucky to have you there.
So when it's
Okay, mine works. Yes.
Good job, Dhruva, good job. So what was the problem?
on,
Mine was set up differently.
Right? So the thing is that if your code is correct, and obviously if you're copy pasting it from Alex's, what Alex shares, it should be correct, right? The next thing to check is just whether your wiring is correct.
greater than 250?
Whether electricity actually flows in a circuit or not, right?
No. When it's brighter, so
And this is a huge advantage of actually doing this online, because we can't physically go and help you with your device. You have to go through that troubleshooting, and you're learning a lot, guys. Trust me, yeah. I think you learn even more than our physical class students, because you don't have anyone coming and actually doing the job for you. You have to physically manually correct it yourself, right? And that's a huge plus of this online class, the one that I actually acknowledge a lot and appreciate.
program yet.
So are you guys all done now and we're ready for jump for some loops?
We can, but then Kranti will miss the.
So we'll wait for Kranti to come in?
Yeah, Kranti and Rylan will also need to hear back from him, right?
Okay, sounds good.
Rylan's fine. Rylan's just got it.
What's it opposite?
Okay, Rylan's got working, yeah. So we're just waiting for Kranti. And Alex, can you just give us a quick update on what's we have 1 hour left, right? So
yes, what we're going to be doing for the next hour is that we're going to look at different types of loops and how do we break out of them, how those loops work, and we also will write our own custom functions.
Mm-hmm. Yeah, I think we want to wait probably for everyone to be on the same page with that. Yeah. So it's been an hour, so let's take a short 5 minutes break and let's get back in 5 minutes, okay? Maybe go to washroom, grab some water, yeah?
I'll want some water, Kim.
We should actually make you keep moving, yeah, every hour, okay? So 5 minutes break for everyone, and we'll be back in 11:05.
Mira, mira, ahí se prende el pelo, lo puedo cambiar, mira. Vamos aquí y cambio el y lo mando. Ahora debería
no, mira, está prendido. Let's done.
Sí. Y no. No. Entonces lo puedo cambiar. Hace solo con cambiar el láser.
Qué chido.
Ahora voy a dar algo porque tengo sed. Porque aquí la palabra va a ser. Entonces.
Y te puse la mandarina, tómate. Cómete la mandarina.
Okay. Si se es un statement. Statement es pues if it is less than 850. Else, there's something else. Well then, turn it off.
Vamos a aprender un montón, ¿verdad? Vamos a aprender un montón, ¿verdad?
Mamá me enseñó eso, pero no, me enseñó mal, entonces se me olvidó mi primera idea. Porque no tenemos, entonces se me olvidó. Pero eso se me hace, pero ese statement, como era muy fácil, porque era solo, if it's greater, es como siempre digo, sí, es como siempre digo, sí, la matita es la matita.
Las matitas, repetí que se me han olvidado las matitas.
Sí, ayer me olvidó, pero
Dijo, no lo hagas ni esto, no.
bueno, eso es
Ya. Cierra. Tranquila. No, no, ya. Ya se alejó, pero no, pero ahorita me van a llamar de trabajo. Yo estaba esperando que me llamaran, pero me voy, estaba acá comprando unos pasajes para irme a Toronto. Sí.
Okay, guys, I'm gonna start assembling the circuit for our next exercise. Is Tim back from breakout rooms?
Yeah, he is.
Everybody's in, excellent. Okay, so I'm gonna create new circuit and we're gonna add some fun to what we have so far. So let me bring in here the breakout board, sorry, the breadboard or Arduino. And I'm gonna bring a whole schwack of different resistors, sorry, the LEDs.
Wait.
Again, you guys don't need to follow him on Tinkercad. You can always go to actually his project on Tinkercad.
Yes, you don't do that on your own Tinkercad because it's just going to be a waste of time. You can just take your Arduino board and start assembling it.
Yes.
Since you already have this thing, so don't remake the connections because I'm making the same thing we had in the photosensor, except I'm just adding it in a separate sketch so that we could have some code back and forth on it, okay? So I'm gonna put a few more resistors. Actually, we have, how many LEDs we have in our kit? 1, 2, 3, 4, 5, 6. Let's use all of them. That's gonna be a really cool disco party.
I have way more than 6 LEDs.
You have more than 6? I have only 6.
I have like 20.
20 in the kit?
Yeah.
Yeah, same.
Really?
Oh yeah, Alex, look.
Am I using some defective kit?
Alex, look at it.
Oh, you got a lot. Okay, well, we have only that many inputs here, so let's use maybe like 6 of them. If you want to use more, you're welcome. We have actually from 2 to 13, so a good 10 outputs. And that will help us to understand loops the best, because this is going to be fun. You can guys start assembling this. So just note where you're putting the short legs to, because that's where the resistor is going to go. And resistor is going to be in ohms, and we'll use it 100 or 220.
But do not try to actually do it in Tinkercad. Do it directly on the board. As Alex wires, now you know how to read the diagram, right? So you can actually use the actual board and start assembling it there. So remember how yesterday we had 2 LED lights with transistors, right? Now we're having just like more. We're adding more lights with transistors.
Alex,
resistors, yes.
One of my LEDs has 4 legs.
Yeah, that one is multicolored. It's a common anode resistor, which you can control with the several pins, and it will illuminate any color you want. So you can control the shade of it.
Oh, okay.
But right now, for this exercise, we use the regular ones.
Actually, use different colors.
Wait. Can I say something?
Yes.
My Arduino page was stuck in the wall, so I couldn't change something. But then I had to eliminate it. But now I need to copy paste it, but I don't know.
What is stuck in the wall?
Okay, so my Arduino page was stuck in the wall of the computer.
So do you need the code?
Yeah, so
you need the code. So it's above. You can copy paste it from where Alex pasted it above.
There will be a new code anyways. Are you talking about this new contraption? We're done with the photoresistor contraption, right?
You can keep it if you want. It wouldn't hurt to keep it.
But
okay, let's see what he has to say. So what's going on? What's wrong now?
Okay, so I had to eliminate it, but now I need to put but now I just put the start, so it doesn't have anything.
So I think what he's saying is that his Arduino IDE got crashed or something, right? And he's trying to find it now, how to bring it back. Is that what you're saying, Ricardo?
Well, what I'm saying is that
can you share your screen?
Got deleted.
Okay.
And I have to find how to get it back.
Okay, can you share your screen?
Okay, wait.
Alex, can you please allow Ricardo to share his screen? Yeah.
Mm-hmm.
While you're assembling it, we can help him.
Alex, are we supposed to be following along with your thing?
Not in Tinkercad, but yes, start building it on your actual breadboard.
Oh yeah.
I just got back, so I couldn't.
Alex, do they need to? You said they should keep the photoresistor. Are they going to use it for this next project?
We need some sort of. Yeah, that's okay. No, we're not going to use it.
Okay, so they can just disassemble that and they can build a new contraption, right?
Okay, so Ricardo, what's up?
Okay, so I tried to so this page was stuck in the wall, so I had to delete it. Then I got back in, but it didn't have anything that I had.
Mm-hmm.
So I tried copy pasting it, but and it didn't work with the copy paste.
Yeah, it lost his code.
Okay.
I don't see anything wrong with it. I think everything is still in there.
Is he missing a bracket or something, or does he have an extra bracket?
No, I just copy pasted this.
No, it's all good.
Yeah. Okay. So does it work?
No, there is an error. Exit status 342 in the program.
I think it was the last line. You see it, Fred?
Oh, wait, no, what? It worked a second ago. We just uploaded this code with him.
I think you can just close this Arduino and open it again and it will work. Just close all the windows of Arduino, then bring it back in.
I need to look at this. I'm hungry though.
You have 2 more open there on the bottom.
On the bottom, you see Arduino logos. Those green goggles. Yeah, with plus and lines. Yeah, there you go. Can
What are
click
those
on them?
guys?
Yeah, just close this too. Too many windows open.
Are we allowed to like cut part of the wires off the resistors because they're kind of long and hard to get in the holes?
You can cut if you want to.
Okay.
Or you could just bend it slightly differently so that the resistor leg is shorter.
Oh, okay.
Okay, we try to close this one too. Yeah.
I saved my sketch in Tinkercad as Alex running light. And
Click again. Yeah, click on it. Yeah, you see how
he can go to open recent and run it from there.
He just still has his 2 open windows.
Let me try to get control here. Request remote control.
Hey. I'm already controlling. What are you
Oh,
doing?
you're already doing it? Okay, sorry.
Is this the error you guys just had?
Okay, last time I already fixed it once.
And he says it got stuck in the wall. Like
He just copy pasted it again. He undid everything you just did.
Maybe there's some weird character there that is part of.
What I did last time is I just replaced the curly brackets with like new curly brackets.
Yeah, maybe
didn't
when
like your curly brackets.
maybe when they copy pasted from chat.
See, now it literally works.
That works, yeah.
It's just the chat curly bracket is wrong.
No, we saw this with Unity the other day when Riley was posting the code into the chat and we were copying pasting. Unity didn't like the quotation marks that come in the chat.
The code behind is probably different, right?
Yeah.
Anyway, there you go. So now it works. It was working before too. I don't know why he recopy pasted.
Well, he says it got stuck in the wall. I think when it gets stuck in the wall, Ricardo, just pull it back by the head.
Oh yeah, that's the point. I tried to do that, but it didn't work.
So you completely kind of moved it to another.
The arrow
It just vanished.
Okay, next
no
time
more
you
screen.
just don't put it in the wall.
Because he's on Mac, I think he can actually he can have several desktops, right? So he's probably pushed it to
No,
another.
that doesn't remove your walls. Like you can still put things in the wall.
It's okay. Don't worry about it. Let's keep going.
Let's go.
Yeah. Okay, so back to our contraption. So what Alex is doing, he's connecting LEDs. Then the shorter leg of LED through the resistor.
Yeah, you look at the shorter one goes to the resistor and to the negative bus. And the longer one goes to its corresponding digital pin.
Alex, do you need the 5-volt bus?
5 what?
The positive bus. Power.
We don't really need positive bus, no. Unless we're gonna use some.
I saw some people who were accidentally connecting the LED to the pin and the positive bus. So just completely remove it.
Okay.
Right. With LED, we only instead of 5 volt there, right? Are we using a pin instead of 5 volt?
Of course.
I think on the first class, the idea was different. Like it was the pin instead.
No, that was just for constant power. This time, if we want to be able to control it, you have to have one side ground and one side pin.
Okay.
Can I go to the bathroom?
Yeah, go ahead, Joanne. Yeah. So we have 45 minutes left, and everyone should be building, following Alex, not in Tinkercad, but on actual Arduino. So now you know how to read diagrams. So hopefully you're all gurus now, and you can able to follow this diagram and build it on physical Arduino. I actually have a set here too that I can color.
My light doesn't turn on when it goes on 8.
It shouldn't yet turn on because we didn't program anything, right?
Probably plugged it into the wrong leg.
Oh, yeah, right.
Yeah, we haven't yet programmed any code to go through the pin state. So for now, just it's always two-step process, right? One, you need to make sure you build that on your board.
5, 4, 3.
And two, you need to make sure your code is actually sending the right signals to those pins where you connected, right?
One cable short.
Can the photoresistor control multiple LEDs?
I don't think so, actually. What the photoresistor does? Oh, the photoresistor. Sorry.
Photoresistor doesn't control anything. The Arduino controls it, and your program controls it. Photoresistor basically detects the lighting situation and helps you.
But he means if you cover photoresistor, can you actually control several LEDs at the same time?
Yeah, you totally can. That's something that's totally up to you. An if statement can have as much information in it as you want. So you could have it control everything on your board if you really wanted to.
Alex?
Yes.
I have a question. Do
Go.
the resistors have to be like what resistance do they need to have?
I put them as 220.
Okay, that's what I'll do.
Yeah, but you can use 100 as well, and you can use 330 as well. The lower the resistance, the brighter it's gonna go. Give me hands up if you guys done building the circuit.
It's so hard to get the resistors in.
Alex, do we need to have all 6 of them on there?
Say that again, sorry?
Do you have to have all 6 of the LEDs on?
I will be programming for 6, but you can make 5 if you want, or 4. It's up to you.
You do like 7?
Yeah, you can do all 10. The more the merrier, actually.
We're gonna do the disco party.
Yes.
Oh my god, these resistors are so annoying.
Guys, try to bend it closer to the body of resistor, like I do, for example, like this, like so that you could get it. Right, and then just plug them vertically. I don't find any difficulty plugging them in.
Whenever I try to put the resistor in, it just bends the wire.
Don't force it too much. Try to do it in a kind of a gentle.
If you do it a little like wiggly, it'll usually go in easier.
Yeah, it's supposed to be firm in there, but you don't need to push it so far that actually sometimes actually a leg can bend itself inside if you push it too hard, and it can catch other buses there inside and create short circuit situation. You don't want this to happen. It's supposed to go there like 5 millimeter in.
Guys, and with LEDs, the one thing I noticed just now, you see, is when you actually bend the longer leg, distance between them is definitely more than just one hole, right? On Alex's diagram, it always next hole, but in reality, it can be like the gap of 2 or 3 holes, like here, right?
Exactly. You can put your resistor like this far apart and put it like that.
So, Alex.
Yeah.
You have the code ready?
Are you ready?
No, do you have the code ready?
Oh, I do have a code ready, yes. But I would like to go through it so that you guys understand, but not barely just copy paste it.
Yeah.
Okay.
One of my LEDs is not turning on. The blue one's not turning on.
You know how to turn on LEDs right now. So imagine if we would want to do this for all 6, right? So what would we have to do? Where is my sensor value here?
What are the ones with four? What are the LEDs with four prongs?
It's a multicolor one.
Oh, can we use them?
Yeah, totally.
How?
I'll show you. So if we do pin modes for those resistors, so for example, I have my LEDs connected to pin 3, 4, 5, 6, 7, 8. So I have to put like 3 output, and then so on and so forth. So I'm gonna show you first the long way of making it, and then a super efficient short way. So 3, 4, 5, 6, 7, and 8. Okay. This is the delineation of how do I designate each of the LEDs pins as outputs on my Arduino. So Arduino knows that when I will be addressing those ports, they will be treated as outputs, so full power is going to go in there. And now if I want to turn them on one at a time, I'm going to have to do our already well-known method is digital write. You don't copy it yet. I'm just trying to explain and make a point. So I'm going to say pin 3, and I want to make it high. And then I'm going to make a little delay.
Wait, I'm not done building.
Yeah, you keep building. I will actually keep the schematic here on the left open. Please, guys, don't modify my schematic. I see somebody's already in and drawing crazy squiggles there.
Seriously, people, can you please? No, I'm trying to use it.
What?
Instead of typing, I'm gonna show you what people call it macaroni code.
Look what happened again.
I think I have a faulty LED or something.
How do you know?
Because it's not turning on.
It's not supposed to until you code it.
Exactly.
No, but like the first one turned on and I didn't code it.
First one is already pre-programmed in your from the last sketch.
Oh yeah.
Yeah.
So imagine now having like 1,000 LEDs. You have a strip that you control in your house Christmas lights with. You have a long strip with the thousands of LEDs in it, and then you're trying to make some sort of animation, running sparkle going through them. So you're gonna have to write a code like this. And this is just to turn them all on. And then of course you would like to have some sort of dimming situation and some blank lights going through. Guys, did you actually squiggle it? What did you do?
Thank you, Alex.
Yeah,
Because
don't move it
cannot read a
unnecessarily.
single thing
Just
on
keep
this
it for
anymore.
instructions. Don't play with it. Oh, whoa, whoa, whoa.
Hey, Alex, can you show us the program?
Guys, don't play with it, okay?
It's not funny. Please.
Okay, guys, if you continue doing that, we're gonna actually do this in separate account, and then you won't be able to access it on your own, okay? So stop doing that, whoever's doing that. Thank you. Because right now we're all on the same Genetech Fusion account, but we have separate accounts. So Alex can just log in with his personal one, but then you won't have access to that. Thank you.
You guys good? All built?
Wait, no.
Not good because people are messing around.
But you got the idea, right? So they all replicate exact same pattern. So if you know how to connect one, you can connect all the others.
Yeah.
3, 4, 5, 6, 7.
All the long legs connect to their consecutive pins. So you can start from 2 if you want. You can go from 3 up, 3, 4, 5, 6, 7, 8, as long as you need, all the way up to 13. And the short legs are all connected by a resistor to the block. So you don't even need to look at it. Once you've connected one, all the others supposed to be very logical continuation.
And another thing you should always pay attention to is on Alex's diagram, minus and plus are inverted, right? It's like in his diagram, plus is on the side, minus is closer to the board, to the middle. But on the actual ones, it's the other way around. So just pay attention to the signs, negative and plus, not so much into like, don't try to follow the pattern. Make sure you're doing it smart and you're actually following plus and minus signs there.
I don't see anything else.
Okay, Alex, and resistors that you're using are 220 or 330, right? Like last time?
Yes. So look how the simulation works now.
Oh, that's nice.
Alex, can you show us the program?
Yeah.
Yeah, can you show the program?
It's a macaroni code, okay? So we're gonna have to replace that with just the 3 simple loops, and it will all solve that for us.
Wait, can we put this program in our main code?
You can? Well, you can actually take it straight from Tinkercad if you want. Just copy it from there and put it in your main code and put it into your Arduino.
Yeah, that way you'll avoid problems with turtle.
Exactly, and stop dragging elements that you don't need on the screen. Somebody change colors of all my LEDs.
Uh-oh, no.
Really do that.
People, can you please just not mess with Alex's
You want to log
code?
in with different accounts, maybe?
It's okay, let them be different color.
Yeah, doing it. I'm not messing around with it.
Make sure you're not.
Wait, did you do the code yet?
It's okay. It's more fun this way. It's like now a much cooler party. Before it was all red. Now it's like a Christmas tree.
Mamá,
Oh.
mamá, ¿sabes qué hice?
Can you please copy paste the code?
It's not that hard. You can just copy paste.
Oh, you
can
asking
make
me to
one.
put it in chat?
Yeah. Yes.
I'll try, but I can't guarantee that it's gonna all go in because chat has a limitation.
Eso va a ir.
What is
You
chat
can
window?
always open the code in
No,
Tinkercad.
no lo voy a copiar.
Rita, can you use your microphone there?
I don't want to know about it.
Okay, it's all there, guys, in chat.
Increíble. Remove for output. Me gusta tanto, Ricky, que hasta me estoy pensando en tomar vacaciones, unos 3 días.
Did you just mute yourself, Alex?
No, I'm still here. That wasn't me speaking Spanish.
That was Ricardo, I think. Yeah.
Okay, now I need a code.
Yeah, I just muted Ricardo.
Well, you did? Okay.
Yeah. But we definitely should learn how to speak Spanish.
Oops. What? Something happened. Oh, wait, what?
Yes.
Okay, are you happy?
All right, so how's it going for people? How are we doing here?
Good.
What's our status update?
I'm still on the resistors because they're so hard to put in.
Okay.
Exactly.
How's Ian doing?
I have a meeting, so I'm gonna run out, but I'll be back soon.
How's
Okay.
okay.
And tomorrow we'll do infrared if everybody agrees.
Oh yeah, sure.
Remote controlled things. And then we also want to learn how to do ultrasonic, which is super cool if you can make like security system.
That's good. That's gonna be fun.
Yeah.
Yeah, my sister taught me about the electrosonic sensor.
So, Alex, we're gonna use the motors, right?
Some motors? Yeah, sure. We're gonna make it in conjunction. So we can make a sonic sensor with the motor working. Like when you sit in front of the computer, it's gonna turn the fan on and give you a nice breeze. How about that?
That would be nice.
Yeah, like the other sets that we have never had the propeller in it. This one actually has a propeller, so we're gonna have some fun with it.
Yeah, but what I need to find is the way to actually mount the motor so that you don't have to hold it in your hand all the time.
Oh yeah, that's a good point.
Find some hot glue and some sticks, or Lego.
Oh yeah, Lego works. That'll work.
Okay, I think Ian has already a thing running on his. Excellent job. Looks very cool. Little disco. Put some music on.
It's
good
not working,
job.
Alex. Alex, it's not working. It's me, William.
Yeah, just give it a second glance and look at if the code is super simple, right? There is nothing that can go wrong with the code. If it doesn't work, it might be one of few reasons. One might be the ground is not properly plugged in, or you connected the wrong legs to the wrong pins. So your short leg is supposed to be connected to resistor and long leg connected to the digital pins. We'll see if you inserted the LEDs the right way in. Pull it out and see where the long legs go. If the long leg touches the resistor, that's the wrong way.
Alex,
Mm-hmm.
my Tinkercad that I'm looking at, basically there's no code and it says connection lost. Changes will be saved on reconnect.
I actually put the code in the chat window there. You can take it from there too.
Okay, I'll do that.
I just basically did the easy way. Do you want me to tell you what the easy way is, Will? Just a second. I'm doing it the easy way. Easy way.
What?
It's my brother. He's singing.
Because I figured out how to do it the really, really easy way.
Oh, okay.
Awkward.
Would you like me, guys, to show you the more effective way, more efficient way to code with loops?
Yes, please.
Okay. So if you can see this code is growing exponentially as you add more LEDs. So instead of 6 LEDs, I want to add like 60, I'm gonna have to make this macaroni code 10 times more long as this. And if you want to change your pins, it's going to be much more difficult to go in there and try to troubleshoot. So this all can be shortened dramatically to just 3 lines of code if you use loops. And there are several kinds of loops, and the one that I will show you first, it's called for loop. So for is basically introducing a variable. Let me go into the, oh, I need to stop simulation for that. I need to go into my code here and start typing 4. And I introduce a variable int I. That will be integer variable I. And I'm going to start with my first port. My first pin is number 3. So I'm going to start with 3. And my int variable is 8. So I'm going to be making the I less than 9. And my stepping would be just one at a time. So I'm going to do I plus plus. You can jump for more than one pin if you want to. You can make I plus 5, for example. This time it's going to just jump every 5 pins. But in our situation, we're just doing it one at a time. I'm going to do 1 plus plus, and I'm going to make a curly bracket. And I delete all that thing here, put curly bracket, and instead of 3, I put I here. You see how much shorter? This loop is going to go for all the pins, starting from pin 3 all the way to pin 8, which is less than pin 9, and incremented by 1, and set all of them to output. So instead of that macaroni that I had in there just a second ago, you know, all that thing in here.
Alex?
Yes.
It's still not working. I've tried like almost everything. That's how you work. Still not connecting correctly.
Do you want to go to breakout room and Tim will help you?
Sure.
Okay, let me assign Tim. Tim, you're in the breakout room 1, so that would be Will, right?
Yep.
Assign to breakout room 1. You can jump whenever you get invited, and Tim will help you out to put you straight there. Okay, for the rest of you guys, we're gonna do the same exercise for the turning on and turning off lights.
Wait, hold on. My LED, it says I have an error, and it says it's like this. It says expected, like a symbol. Oh, except before pin mode.
Actually, mine is also doing this thing. Just a second, let me see. Oh, I put a comma there when I'm supposed to put a semicolon. That's the thing. Sorry.
Wait, before all of them, you need to put a semicolon?
Yeah, when you set first integer variable I, 3, then you put semicolon, and you put I less than 9 semicolon, I plus plus. That's what it is. So I put comma there, it's my bad. Sometimes I get confused with syntax for different programming languages.
Can you please put it in the chat?
Yeah, I will. Just this part? Or everything?
Just the part that you need to.
Okay, I will put just the setup function, okay, so that you could replace just the setup function. But what I wanted to do is first replace everything and then post the final code. But I will do this anyway because it's just a short one. Here it is. It's in the chat. You can replace your setup function with this guy. And now let's try to optimize our main loop as well. Let me stop function here. And I will use the exact same logic. I will take this for loop from here. I'll go into my code. I'll create that for loop in here. And as you notice, we're making the LED light up. So I will just put digital right, high, but instead of the specifying number directly, I just put variable I in it. And that's going to do the magic trick here.
Wait, it's asking me to put a semicolon before the curly brace.
No, you're not supposed to.
I know, but that's what it's saying.
Yeah, I know. Sometimes it's not.
And you want to share your screen, maybe?
Yeah, sure.
Just give me a sec. I'll see. You see, my code works, so that means that this is the correct way.
Can you just copy and paste the whole thing in?
I need to share my screen, Alex.
Okay, let me stop. Go ahead.
Yeah, so it says before this.
Oh yeah, you're not supposed to have that curly bracket there at all.
Oh, okay. And I make it all one?
Yes, and your semicolons for some reason are in the beginning of the line. They're supposed to be at the end.
I know, but like that's what it told me to do, and it says the error's fixed when I put a semicolon before.
Yeah, yeah. Semicolon is supposed to be at the back of the line. Pin mode 1 output semicolon. And next line starts with pin mode 2 output semicolon.
So actually, guys, you're coding in language C right now, right? Arduino uses.
Yeah, I know.
Yeah, and unfortunately, it's not Python. Here, you do need to frame all your statements in brackets, right? So you put the brackets in beginning and the end around the if statements, because otherwise it doesn't understand the indentations, right? So that's how it knows the brackets show the hierarchy inside of the code.
Okay, let's see how it works now. So you see how much shorter this code is? And right now it's super scalable. If I want to make it 1,000 LEDs, this code's not going to grow. This code will be exact same.
I'm having like the same issue again. So I put like a semicolon after sensor value equals analog read AO semicolon. Then it's telling me to put a semicolon before sensor value too.
Okay, let me stop sharing, bring it up. Your code was swarming there with errors. I'm sure if you remove one, it's not gonna fix the rest. So we need to be consistent there. Just bring up your.
Yeah, it's so I have a semicolon right here, and it's expected the semicolon before.
It doesn't expect before. It expects it before, not literally before. It needs to. This line needs to end up with a semicolon like this.
Yeah, I know, but it said sensor value, so I was confused.
Okay, sensor value analog read, serial print. If sensor value visual right high. Do you still need this piece of code or not?
I mean, it's for the photo sensor.
Yeah, we can at the moment, comment it out. I'll show you how to do it. You just put the dashes like this, and it will be not executed, but you will have it in your program in case if you want to use it in the future.
You only did 1 slash for this one.
Go to
there.
Yeah. Okay. So right now it should work.
Oh, so where did you share the code?
Okay, it worked. Okay, yeah, my LED's lit up. Thank you.
Yeah, and let me stop sharing, and I'll share mine. Okay. So I was saying that this is the code that uses extensively the loops. So we have this for statement here allows you to go through your pins one by one, starting from any given pin. In our case, it's 3. We're starting from 3, and we're going to 4, 5, 6, 7, 8, all the way, as long as it's less than 9. So less than 9, 8 would be the last one that we're going to go through. And we assigning those pins as outputs. Now inside our loop function, we use the same thing. We go through all the pins from 3 to 9, and then we light them up all in turns. We start 1, and we turn it high. Then we wait 1 millisecond or 10 milliseconds, and we continue go until all of them lit. Then we wait for 1 second, and we go through them once again, and we're turning them all off. Let me start a simulation and you see how it works, right? They turn it all on and then off. And it all repeats since we're inside the main loop. Now, if I want to go the other way around, I want all the lights go bottom up and then return backwards the other way around. So we can go from pin 9, then we go to pin 3, and we go minus, minus. Let's see how it's going to work. You see it goes up and then goes down the other way.
Oh, that's cool.
We can put another long delay between those sections.
Can you put this code in the chat?
Sure. Actually, this will have to be 2.
Yeah, 2
And
parts.
this will have to be 8, since it's starting from 8 and it goes to 3. Okay, so let's see. It goes up and then goes down. And it goes up and it goes down. Okay, so I'm going to copy this text here and put it in the chat window. Somebody said it's not working. Who is that? Crancy. Mine is not working. Crancy, would you like to have Tim help you? You can switch yourself to the breakout room number 1, and Tim will be there and he will fix you up. In the meantime, I will post the code for everyone in the chat. And the last subject that I wanted to cover in this class is creating the custom functions. And this is a super cool thing. And it's done like this. So I'm just going to copy this text myself. And I'm going to go into my macaroni code here. And I'm going to replace it with the with this code. And I'm going to auto format so that it looks real nice. So I want to save this code as the standalone function so that we can just call it by name and it will execute our nice running light next time we want it. So for example, if we decide to create that running light part of our Christmas decoration strategy with this photo sensor that we have built before. So we can totally do it. And the way to do it is we can click on that little arrow on the right, create new tab, and give a name to the tab, call it running light. Running light. Understood.
Alex?
Like this, yeah.
So I'm pretty sure that one light always stays on, so I adjusted the code so that I changed it to 2, so not all of them turn off, and then they all turn back on.
Was that?
So like somewhat like this, like they turn all the way off at the end instead of just having this one stay on the entire time.
Yeah, you can modify this thing by changing this variables here. If you want it to stay on at all time, you can change this to 3, and it will stay on. So it's not going to affect that LED. So you can manipulate it. So in this one, we're going from pin 3 to pin 9, and we keep increasing it with every step. In this game, we go down from pin 8 to pin 3, decreasing it with every step. So that's what it is. So right now, we're going to create a new function, and we're going to call it void running light.
Running, you have a spelling error.
Running late. And we're going to take all this code in here, copy it, and paste it inside that function. So now if we want to call it, we go in here and we just call it by name.
Alex, can you show me how to make the
new tab?
I forgot the function again? Can you show me how to make the function again?
Sure, just a second. Actually, I would like to wait for the guys to come back from the breakout room.
Okay.
And in the meantime, maybe we can go through the code line by line. So make sure everyone understands it, right? Because I think when you were explaining, everyone was head down, building the contraption there.
What?
Oh, yeah, well, we already kind of gone through it. So inside the function, we have.
Yeah, when you were explaining it, like everyone was building their Arduino stuff, so
Okay.
I don't think they actually listened.
So you guys still not clear how it is done? Anybody have questions about it?
Okay, guys, I want to just let you know like that we have actually Python coding class when we explain all these concepts of the functions, loops, variables, if statements, and we do even way more there, arrays and more complicated things. So that is pure coding class. So we highly recommend you if you want to dive in more into the actually coding side of this Arduino, actually to join that class to learn, or any, for the matter of fact, any coding class. What Alex shows you literally high level, where he actually shares the code so you can see on your Arduino what you can do with it. So the main idea here is to actually help you understand the circuits, how the electricity flows. Coding, you just cannot work with Arduino without it, right? So Alex gives us the ready available code. I'm pretty sure many of you do not really understand what's happening with the code. You're just copy pasting it, which is fine, which is totally okay. But the next step for you would be to actually learn more coding to understand what's actually this code is doing, right? So obviously we can't cover that all in 5 days, but for those of you who are already gone through, and I recognize from the faces, I've seen many of you in our Python class, so you know the concept of functions, right? You know the concepts of loops. You understand the concepts of if statements. So what Alex showed you just now, how you just do the macaroni code where you just copy paste many times the same code. And obviously you can optimize it by putting it inside of the for loop, right? So that's exactly what he did with the code. But he showed you how to do it in the convoluted long, literally describing every step of the process. But a golden rule of any coding, if you find yourself repeating the same code again and again, that is a very good candidate for putting in a function or for putting in a loop so that you can actually bring it later in a shorter, concise manner. That's what separates the good coder from bad coder, right? The good coder's code is short, concise, and self-explanatory, right? So let's just go step by step through the Alex. Do you still have the old macaroni code? Can you maybe put them side by side and explain how you converted the macaroni code into this code?
Let's see if I can do it.
Mm-hmm. I think it's still in the chat. You can just probably copy paste from there.
That's okay.
Yeah.
There you go. So we're comparing this code here on the left with this code here. So you see how
Can you
much.
keep that code on? Wait.
Yeah, this thing on the right is macaroni because it's very similar in its structure, and it just continues on and on and on. So if we to increase it to 1,000 LEDs, it's gonna be 1,000 lines long every section. So every time you want to turn on all the LED strip, we have to go through each of them individually and hard code them into the code. So this is like beginner programming level.
And you can
if you would like to be more efficient.
It's the same code. The only difference is just the pin number, right?
Exactly. Yeah. So if there's any repeatability in the code, anything that keeps repeating itself over and over, you can replace it with the loop.
Guys, Ayan, is that you? Can you mute yourself? Yeah, go ahead, Alex. So when you see something repeating itself like this, it's a very good candidate for the loop. The only thing that changes is the 3, 4, 5, 6, 7, 8, and well, we can replace it with for loop and replace that with some X or I.
So I will simulate this thing here to be having like a 20, right? So if I'm going here and I'm gonna keep adding stuff, right? Our code keeps growing. I just put a different number here: 9, 10, 11, 12, 13. This Arduino Uno doesn't have more than 13 pins here, but there is Arduino Mego that has way more. Imagine that we have one of those, and we keep adding those LEDs, and our code keeps growing and growing. But in reality, this code is very dumb because everything that is changing here is just the number of pins, but all the other stuff is keeping the same. So why not to just automate it by putting a little loop saying that we start.
Alex.
one pin, and we're finishing with another pin, and we just go through all of them.
Ricardo, can you please mute yourself for now? Let Alex explain
It's
the
okay,
code.
I can, yeah.
Thank you.
So you see the difference? This whole chunk in here is exactly the same as just these 3 lines.
Those 3 lines do the same thing, right? They start with I3 because that's your beginning input, and they end with input 9.
Exactly.
Right?
Well, in here, this is 19 inputs in the right. So I'm making this 20 on the left, and that's going to do exact same work as that whole chunk in here. So if it's going to be 1,000, it's going to be like twice. Yeah, go ahead.
And I++ here just shows an increment. It can be I plus 2.
Exactly. This I++ is the same as I plus 1.
Jumping step, right? Yeah. So it's just a jumping step. It can be if you need your pin to be every second number, like 3, 5, 7, 9, you just put I plus 2 there, right? So in this case, I++ means just I plus 1, right? So if your I3, next time you go through this loop, your I changes to what?
Everybody muted, but it changes to the next available number. Not available, but next
and
number.
Our step is I++, so the next number will be, Ian, do you want to help me? Ian? So if I start with I3 and going through this loop, so next time I run through this loop, what will be my I?
4.
4, right? Because my step is 1. So I just will go to the next number, right? And 4, you can just assign that to your output again. So the next time you go to that loop, so what's the I gonna change to?
5.
5, right? Yeah, so it's gonna increment in just literally takes every next number because of which part in the loop? Which part of the loop actually dictates that it takes the next number?
I++.
I++, exactly. Yeah. Is that clear to everyone? Yeah. I want to hear from Kranti if she's
Okay, and there was a question, how did I create the function? So who asked that? That was Ayan?
No, that was Ajwad, I think.
Ajwad?
That was me.
Okay, so Ajwad, I'm just going to repeat this quickly. So what I did is I clicked on that little arrow here. I created new tab, and I gave it a name. You can give it any name you want. It doesn't matter. So you can call it my first function if you want to, but I give a descriptive name because I want to know in that tab there is a function that creates running light effect. So I created it running, created one, and now I have a new tab in which I can put that function. And function starts with the word void. I created a void, running light, 2 brackets, and then curly bracket, curly bracket. Anything between curly brackets is going to be this thing that's going to be executed. So I took everything from our main loop and I plugged it in here. Okay, and now this is the name of the function. So in order to run all this code inside, you just call it by name like this, using the exact same name with those simple brackets. I copied it, and inside main loop, I just pasted this, running light. So when the main loop starts, it's automatically going to call that running light function, and it's going to be executed. And this way, your main program stays nice and tidy and clean, but you can create as many tabs as you want. You can make 25 tabs, and in each tab, you can create different patterns. One going to be running lights up and down. Another one going to have individual light, go in and out, go in and out. Another one might have a strobing effect. And all you have to do is give them the names, descriptive names, like strobe, running light, sparkle, rainbow, things like this, and you create each individual tab for them, and you're going to have all those functions in there, and all you have to do in your main program, just call it by name. So if you want a running light, you can running light. If you want strobing, you call it strobe and give it a name, and it's going to run. So you have to like choose which one you want to run. You comment one out, and it's going to be strobe. So minimum alteration to your main program going to create completely different effect. You don't have to rewrite your program anymore. So this is a very powerful and cool way of writing code by creating individual tabs with individual projects in it. You can even have like your photo sensor, for example, in there as the sensing mechanism, and you can call it just measure light. So you measure light, And if your light is below a certain level, you illuminate something by calling another function illumination. So I find it a little bit difficult to understand initially, but it's so elegant that I think if you look at it carefully, you will be super pleased of, and it's very, very logical how it looks.
So think of the functions as if you have the function in code, you're just putting it in the box, call function and call the name of the function. That's pretty much it. That's a standalone program, right? So that you can call from any other code. So that's what Alex just did. So he took that code that we know it works, we tested it, he actually gave it a name, he turned it into the function. Just by making it a separate program that he can then, because it now has the name, he can call that function from any other program. So that's all he did.
That makes more sense.
12 o'clock now, and so those of you who still need help, stay online. We're here to help you.
I think Tim's still working with Kranti, and they missed all that function thing. We're gonna have to show it to her too.
Yeah, no problem.
And tomorrow we're gonna include this in the review session in the morning, in the beginning of the class. So don't worry if you don't understand it right now. We will have another opportunity. And we would like to give you an advice that try to use it as a homework. Try to create another copy of this running light, but change the sequence, change the duration, and create a new tab with a different function, and try to create different effect with your project. So right now, you have this thing running, like all of the lights illuminate and then goes back. Try to make one light bounce back and forth. So that would be a homework. Try to think about how you can make it. And with all the knowledge that you got today, it should be sufficient for you without anything additional that you need to look up. Just go into the function, try to tinker it into one bouncy light. That will be homework for tomorrow. And if it doesn't work, don't get too sad, because we're gonna do it in the morning, and it's like super easy.
Can you please can be more clear? What do you mean by one light bouncing?
So right now we have all string illuminates one after the other.
Yeah.
And then it goes back.
That's
to off.
actually
So what I want to have one light going in and out, bouncing between the otherwise dimmed.
With no delay in between, just back and forward, back and forward.
Yeah, exactly. Just one light bouncing. It's like a ping pong.
Okay.
I've already done that.
Very good.
I can show you the video, but I can't.
You try to, instead of lighting up every LED, try to do every second one. What would you change in your code to do that?
If you want to be super advanced, try to simulate physics. Imagine the light is a ball, and you want to have it bounce like this, bong, bong, bong. And you can even simulate a little acceleration and deceleration there as well. So you can make the speed, the delay with which the ball propagates, change from one to the other. So when it gets higher, it gets slower, and then it goes down and goes super fast and goes back again. So if you're up for a challenge, try to challenge yourself this way. Play with the delays inside your main loop, and try to make it look as physical, realistic as possible. So pretend it's a computer game, and you make it like a ricocheting ball.
If that's not too much, but the program minimum here is for you guys right now. It has a pause between the lights on and then the lights off. So what Alex is meaning, just make it non-stop. Lights on, off, right? No delay in between. So that's a homework. You already have everything. And don't disassemble your contraption once it's built, because tomorrow morning we want to see them, okay?
Don't disassemble. Did you hear that?
Yeah. Okay, and
just set it aside on your desk. Yeah, you don't have to pack it all up into the box.
Yeah, just pack everything else but your Arduino and your board with your contraption on it, and show us tomorrow what you got, how your lights are running. And again, everything is the new code isn't on the Tinkercad, is it? The Tinkercad has the macaroni code.
Tinker has a macaroni code. I can actually rename it into macaroni. Running light macaroni.
No, can you actually put the real code, the short code in the Tinkercad? I want to make sure they have access to it when they do the homework.
Oh, okay.
Yeah, okay, yeah. Because once we close the Zoom, they're going to lose access to chat. There you go.
Sorry, I lost internet.
Dhruva, that was you? No worries,
Yes.
you guys are still around here. So if you're good, if everything works, if your lights are running, like this, yeah.
My lights are running though.
Perfect, then you can sign off. Otherwise, stay online and we will help. Okay? Thank you for today.
Thank you. Bye.
Bye. Alex, you can stop recording. Yeah.
Goodbye.
Bye.
Bye.
Basically,